Hi folks, there was some requests for some extra assistance with those word problems from that review, so I'm going to just make a really quick video for you. So I have written on the screen that there are three main formulas for this chapter. The first formula is the most basic form of an exponential function, y equals a times b to the x. Typically, in word problems, this is what you're trying to get your answer to. It's not what you're trying to put your formula into to begin with. All right? So your final answer should always look like y equals a number times another number raised to a power. Okay? So that's why number 1 is included in this unit. Number 2 is usually what you're going to use when you are working with exponential growth and decay formulas, or growth and decay problems. All right, so we have y equals a, which remember is that starting value, times 1 plus or minus r, which is your rate of decay or your rate of growth. All right, and then t is your time. Remember that you're going to use 1 plus r if you have an exponential growth and 1 minus r if you have an exponential decay. Now our third formula, I have a very clear line that this is only for compound interest. And that formula is that the total amount accrued, A, is equal to principal, what you start with, times 1 plus your interest rate over the number of times the interest is compounded a year, all raised to then t, where n is, again, the number of times the interest is compounded each year. But again, that is only for compound interest. If you don't see the words compound and interest in the problem, it's not for a compound. You don't use that formula, okay? So let's go ahead and start with number 4, see if the words compound or interest come up. So it says, you take a dose of Excedrin for the headache that you have from staring at screens all day. Each dose has 500 milligrams of acetaminophen that decays at a rate of 15% each hour. Write an exponential equation to model this situation. Did you see the word compound or the word interest in that problem? Nope, so we are not going to be using equation 3. So we're going to be using equation number 2, and we know that we're going to be using equation number 2 because we are given a rate, right? So it says that each dose has 500 milligrams. So I'm going to go ahead and write that down. Even if I don't know what that number is yet, I do know that it's an important number. Then it says for the rate, it says that it decays at a rate of 15%. So we are explicitly told that our rate, our R, is 15%. Now remember, you can never, ever, ever leave it as a percent. You always want it as a decimal. So what we'll have to do is either divide by 100, all right, or I remember that all you have to do is move your decimal 2 places to the left. 1, 2, all right? So now I might have my new R as 0.15, all right? So I have my R. Now I still need my A, right, my starting value. And the only other piece of information that we have is the 500. So we know that 500 has to be our A, has to be our starting value. All right? So our A is 500. And we don't include the milligrams because that just is telling us the units we're working with. All right, now let's go ahead and try to fill out our formula. So we have y equals a times 1 plus or minus r to the t. So we know that our a is 500, so I say y is equal to 500 times 1. Now remember, plus is used for growth and minus is used for decay. Typically, if you're working on a growth problem, it'll either say explicitly that it's a growth or that it's growing or that it's increasing. If you're working on a decay problem, it'll either tell you that it decays or that it's dying or that it's getting smaller, right? So something like that. In this problem, it says that we have 500 milligrams of acetaminophen that decays at a rate of, all right, but the big key here is decays. It tells us we have to use a minus. All right, So now our r we have as 0.15, 0.15. All right, so we plug that in, and that just gets raised to the t power. So t is our variable. I know normally x is our variable that we're used to. We're working with time, so our variable is t instead of x. And it's just a letter, it doesn't really matter. All right, our final step is to go ahead and simplify this stuff inside your parentheses. All right, because that, since it's 1 minus some stuff, you still have work to do, right? Because you can minus those things. So if we minus those things, we'd get y equals 500 times 0.85 to the t. So just like I told you, that your first equation's always the form, right? The form of your final equation or your final answer. So we have a, right, our starting value, 500. And then we have our b, which is 0.85. And it also tells you, since b is less than 1, it shows you that it's a decay. So since you know, right, that it's supposed to be a decay, if you got like 1.85, you know that you did it wrong. Or like 1.15, right? Something bigger than 1 is always a growth, and something smaller than 1 is always decay. All right, so that's all you have to do for number 4. Now number 5 is a little bit different. It says that your grandparents put $1,000 in the bank for your college fund the day that you were born. If the account earned 17% interest compounded monthly, how much money would the account have after 18 years? All right, so the big thing here, we are told this interest is being compounded. Look, those are our 2 words that we were looking for our third equation. So you already know that your third equation is going to be a equals p times 1 plus r over n to the nt. Now let's see if we can't figure out what all of these pieces are. So remember, your number out front, right, this number here, this p, that's always your starting value, okay? Anytime you're working with exponential growth and decay and interest, those sort of things, the number that's out in front, your coefficient's always your starting value. So our starting value in this case, it says your grandparents put $1,000 in the bank. Okay, well they put $1,000 in the bank, so that's our starting value. So we say P is 1,000. All right. So we know that we're going to need some sort of percentage, some sort of rate, because we have that R. All right. So we have this R here. And if we read through, it says, if the account earns 17% interest compounded monthly. Okay, look, that's 17%. That's that percent we were looking for. All right, so our R is 17%. But remember, just like last time, we don't leave it as a percent. We always, always, always change to a decimal. So I'm going to go ahead, take my decimal point, move it 1 space to the left, now 2 spaces to the left. So I get my R is 0.17. All right, now let's figure out this n. Remember that n is the number of times the interest is compounded. The hard part with n is that it's always in word form. So you'll see that it's either compounded monthly, compounded quarterly, compounded yearly, right? Like those are all terms that describe how many times it's compounded, your n. Okay, so oops, that is not a highlighter. So our n value, right, is how many times it's compounded, all right? And it says that the account earns 17% interest compounded monthly. Okay, so this monthly is the key piece. If it's compounded monthly, well, you have 2 options. One option is return to day 37, look at the notes and figure out what monthly is in terms of n, what yearly is, what quarterly is, those sort of things, right? Or you can think about it. The interest is compounded monthly. That means once each month, the interest is compounded. Since it's asking for how many times it's compounded, right? N is the number of times that it's compounded in a year, right? The interest is compounded in a year. So if the interest is being compounded monthly, then that's once a month. How many months are in a year? So your n is 12, all right, because there's 12 months in a year. All right, so then we come to our last piece, the only other thing that we'll need. Oops, again, that's not a highlighter. Ugh. You'd think after so many weeks of practice. Anyway, so we are left with our t. And our t, well, if we keep reading through, it says, how much money would the account have in it after 18 years? So 18 years is our t. So we say t equals 18. All right, so now we're just now we're going to go ahead and set it up. So we still have our a, right? Because that's just like our y. That's whatever our answer is, the total amount. All right, and so we have a equals p, which is 100, or no, it should be 1,000. Our p is 1,000. All right, it's 1,000 because of this right here. All right, so we have 1,000 times 1 plus, all right, since it's interest, the amount's always growing. That's why you always have a plus. Then your our r is 0.17, all right, over n, and n is 12, to the nt, so 12, because that's n, and t is 18. Now, all you have to do from this point forward is go ahead and plug and chug, right? You have the numbers plugged in. Now you have to see what the solution is. Now, it's really important that this piece here, this 0.17 divided by 12, your r over n, that's a division thing. So you always have to do that one first, or at least I would strongly recommend doing that first, or at the very least, put parentheses around it when you're plugging it into your calculator. If you don't put parentheses around it, then your calculator, since it's a computer, it's not as smart as it thinks it is, and it messes up. It thinks that you're saying 1 plus 0.17, which then is all of that divided by 12, instead of 1 plus 0.17 divided by 12, which I know sounds different. It's the difference between 1 plus 0.17 over 12, which is what your calculator would read if you don't include those parentheses. Okay? What we have is 1 plus 0.17 over 12. All right? So that is a really, really big thing. That's why I am making sure to make a note of it. But once we go ahead and simplify that, all right, so we have 1,000 times 1.014. Remember, I'm just including 2 non-zero decimals, all right? All right, and then 12 times 18 is 216. So I'm going to go ahead and take this 1.014 and raise it to the 216th power. 1.014 to the 216. Okay? So we're left with 1,000 times 20.15. So 1,000 times 20.15, all right, gets us $20,150. So that's how much you would have in your college fund after 18 years, which doesn't sound like a lot in terms of like how much, which actually, so it sounds like a lot because it's $20,000, but in terms of how much colleges, it's at least a good start for the vast majority of colleges. Anyway, not important to the video, just a little superfluous information. So that's how you're going to be solving your word problems, all right? Problems like number 4, you're going to start using y equals a times 1 plus or minus r to the t, all right? And you only use equation 3 like we have over here if we have a problem like this one where it says interest or compound, all right? So hopefully that helps you, and feel free to reach out if you need any more help.